Hey everyone, I'm Dr. Bob, and in this video we're going to set up our character controller script which will allow our Pokemon trainer to start moving through that beautiful forest area that we have. Let's take a look. Okay, so this is not the project that you were expecting. I mean, there are no Pokemon or trainers here, but this is actually Unity's third-person template. Because Unity provides these free templates for a lot of different game genres, and they are programmed by professionals. They're very good, and you can use them as a starting point for your games, which I recommend you do. However, to learn how Unity works and to learn how to make games on your own, this is not the best starting point. So what we are going to do is we're gonna take the bits and pieces from these templates that we would just be, it would just be silly not to use those, but we are going to code a lot of things ourselves so that the movement and most of the higher level game logic is gonna be our. And let me give you an idea what Unity actually provides. So if you click on scripts and you double click on third person, we are gonna load JetBrains, which is on, or Writer, which is on my separate monitor. And you can see this is the script that controls, that is the third person controller for this specific template. So, you can see a lot of different things here, such as rotations, velocities, all things related to movement and player input. And it's quite a bit of code, and it is all integrated really well with Unity's engine, which is great, but as you can tell, this is quite a bit, and this has a lot of different use cases. So we're going to write our own version of this, but this gives you some idea of where to look in the Unity template to find the code that they've written. Anyways, let's get to our Pokemon project. So we're back now, and as you can see, we have a trainer model, we have a PsyDuck model, we have a Pokeball. I put them in a folder named models. At some point I was calling this folder source, so adjust your file structure to match whatever is here. And yeah, so let's start with getting rid of PsyDuck because we are going to work with the trainer. That's what we're going to put code on first, and we'll deal with PsyDuck later. So bye-bye PsyDuck. You can just press delete to do that. And now we are going to look for a neat little spot where the ground is fairly flat. I think I saw one up here in mine, but your game is going to look slightly different, obviously. And then I am going to import the trainer mesh into, or place the trainer mesh into the game scene. And it should look like that. And the important thing to pay attention to is the scaling should be correct. If not, you probably want to fix the model in Blender. And you want to have the green Y arrow pointing up, blue towards us, and red to the left because we have a left-handed coordinate system. And yeah, that should work fine. All right, that means it's time to make a script and get some motion going here. So we'll start with going to our assets folder, and we'll make a folder here called scripts. And actually, I think I got a failed to write error, but it looks like it worked fine. I'm actually going to, I have a whole bunch of terrain files here. I thought I already did this, but in case you haven't, make a terrain folder, put all the terrain files in the terrain folder, and you can drop that into your scenes to just keep a clean house. So then we're going to open the scripts, and I'm going to clear this real quick because this is absolutely irrelevant. And we can right click, create C# script. All right, and we're going to call this script character controller, or we can call it player controller. That's a better term in this case, I think. I'm not going to use a prefix for scripts because I don't like using prefix for scripts. And then the assemblies are going to load for a second, and we should have a script. When we double click it, Unity should open Writer. And for me, that's happening on my other monitor, so I'm dragging that over so you can see it as well. And there we go, it's loading. And as you'll see, the script at the start will be preparing the solution and doing a bunch of things here. And the colors still need to update. You can tell that the colors aren't what they are supposed to be. For me, depending on what your color settings are, they might be different. For me, a player controller should be orange. So now we have everything. Apparently there's a JetBrains Rider package update. I'm not going to worry about that right now. I'll do that after the video. And voila, we have an empty scene now. And as you can see, we have a class called PlayerController that is a child class of Monobehavior. And Monobehavior is, so Monobehavior, thanks Ryder, is the base class from which every Unity script is derived. So Monobehavior is going to pretty much be your game loop, and it's going to be going on and on and on every frame so that actions can occur on every frame in your game. And it has a lot of interesting methods, including the start method and the update method. So I'm going to actually double click this, press F1 so that we can get the documentation for it. Because here you can see some of the methods of Monobehavior. It's not all of them. And start is a method that is going to run one time. So it's called on the frame when the script is enabled just before any of the update methods are called for the first time. So when the script is enabled, start is going to happen first, but only once. And then it's going to run update every single frame. Now, there's also an awake function. And awake is similar to start, except that awake is only called exactly once in the lifetime of a script. So only absolutely once, even if you would create another version of the script, it's only going to come out once. So it can be useful in certain cases, but usually the start method is absolutely fine. Another thing to be aware of if you haven't really used this much, you can also, once you open something in Rider, it will open the Unity documentation, but it will open up the scripting manual or documentation or whatever it's called. You can always click on switch to manual, and then you get into the manual of Unity, which has a little bit extra information, and it's written more like a book format rather than just a reference. So that can be really useful as well. And as you can see here, they're giving more explanation about these events, in particular start and update, but there's also one when an object becomes visible or when there's a collision, enter and destroy, which are very important methods for the Monobehavior class as well. So yeah, that's pretty much what we need to look at here. We have an empty script, which is derived from Monobehavior, and we have void start and void update. So I'm assuming that most people watching this video are going to be familiar with object-oriented programming to some extent, but in case you weren't, so void basically means that's how you declare the method. It basically means that this method is not going to output anything. There's not going to be anything being returned here. So that's why you write void. So let's say this method, if this method would return a Boolean, you could write bool start instead of void, but that would never work for the start function. So yeah, anyways, I think that's enough, just about the general script, and we can start doing some things now. How about we start with maybe some ground movement? So ground movement means, that's something that we are going to put in the update because we want to update our position of our character pretty much every frame, not just when the script runs for the first time. So I'm going to put a comment in, which you do with the 2 slashes for ground movement. And we're going to start by declaring float as a variable. And our float is going to be equal to, well, we want input. So there we have input already. Thanks so much, Ryder. Input, and what is it exactly that we want? I would like, here we go, get axis. I would like to get the axis, more specifically, and these are all coming from our input manager. So I want to get the horizontal axis. So I'm just going to double click on that, and then I'm going to put a semicolon. And you can see how great Ryder is helping us out here. But I'm going to go back here to our project, and when you do that, it's going to recompile. But we're going to try to stay in Ryder as much as possible so we don't have to do this too often because that just eats up time. But if you go to the project settings, and I need to drag this in from my secondary monitor, you'll see that there is an input manager here, and you can open up the axes, and here you'll find a bunch of default names that Unity has already set up for you. So the horizontal axis is basically left and right input, which is typically A and D on the keyboard, or it might be connected to a gamepad even. And Unity has a lot of built-in things for you that way. So A and D is alternate controls for it. So WASD will work if we refer to horizontal and vertical, like so. So I'm just going to get rid of that, but I wanted to show you that in case you want to change the input there in any kind of way. So yeah, that's going to be our X, and then on the Z axis, which is left and right, No, actually it's towards and backwards. We're gonna do pretty much the same thing. So we want a floating variable, and it's input again dot get axis, and this time we want to find a vertical. There. So what this will do is it will make two local variables that we're not going to be able to access through another script, because we're not declaring what it is, which means that our access modifiers are set to private by default, which is fine because we don't want these variables to be usable outside of our method anyways. So float x, float z, I mean, we could just as well have written private, but it's kind of redundant. All right, so yeah, with that we should be able to get input on the x and z axis, and I'll show you that by quickly doing a little debug. So I'll type log, and Writer will translate that to debug.log and I'm just gonna put x in there. Here we go, and then I'm gonna save, and I'm gonna press play here in Writer, not even go into Unity, and I'm going to my Unity log, and oh, looks like Unity is still doing something. Oh yeah, I'm not running this script anywhere yet, so nothing is going to happen, obviously. Oh dear, that's silly. Okay, so the next thing that we're going to do then is make sure that the script is actually active somewhere. So let's go back here, and we're going to select our character, and we could add the component manually, or we could just drag it in here. And now our player controller is attached to our trainer, who we can actually rename to trainer here. I think that's going to be good as well, so we know where our trainer is. So the script is active now. You can enable it or disable it by using this, which can be convenient for debugging. And well, since we're in Unity anyways, I guess I could just run it in here. So I'm just going to press play. And if all goes well, we should be able to see, well, yeah, our camera is in a weird spot right now. But if we go to our console, we're seeing 0 here, which means that we're not getting any input. But as soon as I start pressing A and D, because I'm putting the X value out, you'll see how it changes and how it goes to close to -1 to close to 1. So now I'm pressing D entirely, now I'm pressing A entirely. So anyways, we know that our code is working, so that's a good thing, right? Wonderful. So now you can see that while we were doing that here in Writer, in the log under Unity, everything's there as well. So if we just wanted to look at what our code was doing, we could have done that in Writer. We didn't even have to go to Unity for it. So that's kind of cool. You can clear it out, I think, hide errors. Which one is it again? There is a way to, here we go. I just need to pull it up a little bit further. Press on this, and now the log is clean again. So we don't need to keep track of this at all. Actually, you can click here to make it go away again. So I'm just gonna grab all this, delete it. There we go. And now we have that in there. So what I would like to do now is I would like to move my player around. How do we do that? Well, we can grab our player like so. And as you know, every object in Unity has a transform. You can see it right here. It has a position, a rotation, and a scale. So what we're going to do is we want to access this position basically, and we want to mess with it and move it about. So how does that work? Well, first we want our player controller to be aware of where our transform is. So we can just grab it, and we'll start writing, let's say player transform equals to transform. So this is turning red because we didn't declare what type of variable we're getting here. So what we could do is we could just write var, and then it's implicit, and that's really short to write. So it could basically be anything when you write var, or we could write transform, which would specify that player transform, the variable, is going to be a transform, and it is equal to the transform of our game object. So you can read here, man, Writer is really giving us a lot of information. The transform attached to this game object, that's what this is referring. Well, this transform is in the namespace Unity engine, and it is the position, rotation, and scale of an object. It's actually an enumerator or component. So anyways, so we have a variable now called player transform. that is equal to the entire transform of our game object. Wow, I'm saying transform a lot, don't I? Which, if you hover over it, is, oh, it's not specifying, but it's position, scale, and rotation, right? All right, and yeah, just for reference, you can pull up the external documentation if you want to read more about that. I feel that this is a lot of information just about a transform, but I'm just trying to teach something here. Okay, so what we would like to do now is we would like to mess with that transform so that we can move the player's X position to where the X wants us to go, and the Z position where our input wants to get us as well. Now, Unity actually has a lot of code already built in for this, and we are going to use that code. So we are going to go into our editor again, and we are going to add the player controller class that Unity has built in. So to do that, we are going to select our trainer, and we're going to add component, and we're going to look for what is called the character controller. And we're going to add that. And as you'll see here, there's a couple of things that need a little bit of work, because the character controller immediately will create a capsule, which is a collider. So this is a bounding box that will determine the space in which our character is going to bump into other things. And, you know, if the bounding box, the collider of this character goes against the collider of, say, a tree, the code is going to stop it from doing that. Now, usually when you write this code, you're going to have, when you write code for a video game outside of an engine that doesn't have this already baked in, you're going to have to write code to do this type of behavior, but Unity has it all baked in, and it would be silly not to use it. So what we're going to do here is our collider can be as tall as our character, which I believe I put at 182. It might be different for you. It depends on how big you made your character in Blender, but I think I went with 182. And we want this point of the collider to be in the middle. It's not the reference point for the character, but it is the reference point for the collider. So let's put the center of it at 1.82. And this is really cool. In Unity, you can just do some arithmetics like that. So divided by 2, and now it's literally nicely in the center of the mesh. So that's neat. The radius, do we want it to be a little bit bigger or small? I think this is actually too wide for now. I mean, we'll see as we go along, but like half of that, it looks a lot better. I feel like it's sitting a little bit higher than it is, but it's not important for this type of game, honestly, because there's not going to be a ceiling that we're trying to get into. And a character controller, it's actually a function that has a lot of code for movement. So it can have you move over slopes, it can have you move up steps. There's a lot of different variables going on here. There's this question mark that you can, if you want more information about these things, read the documentation. I'm not going to go over it, but as it says here, it takes a lot of fine tuning, and we'll probably end up having to fine tune a little bit as well to make sure our character doesn't get stuck. I mean, that's part of using a game engine these days. So anyways, but we have a character controller now, which is basically a class with a lot of code for movement, and we're just going to use that class to move our character around. And we'll get back to writer and we'll start working with it. So what we're gonna do is we need to know what our controller is. So to get our character controller, we're actually gonna declare a variable first, and we can do that at the beginning of the class. It doesn't need to happen in start necessarily for this. So we are going to create a private character controller, and we are just going to call it controller, I guess. I think that's a good name as any. And yeah, that works for me. I think that's all it needs to be. Just a semicolon so that we know that we're at the end of the specific statement. And yeah. Now, one thing we're going to do is, actually, let me show you this. If you set something to public in Unity, like so, okay, it'll say unchanged here. For one, because Writer is keeping track now of what's going on in Unity. And if I go back to actually, let me close this real quick here. There we go. So if I go back here now, you'll see that there is a spot here, a field in our prefab really, or in our character that says controller. And that's because we set it to public. So once a variable goes to public, your editor can actually access this as well. So that's really neat because we can make changes here, and that's how they do these types of things for the character controller script. However, when we set it to private again, that's going to stop happening, and the unchanged goes away as well, because it'll not say unchanged when you actually change something in the editor. But as we can see here now, once it reloads the script assemblies, it'll be gone because it's private and we can't access anymore. How do you fix that? How can you have a private variable? Because like sometimes you want to have a variable to be private so it can't easily be adjusted by the rest of your code because it's something, I don't know, something private, right? So you can go write serialized field in front of it, and a lot of times people will write it like this, and you know, since there's no semicolon here, it's still the same statement. So serialized field will do that, and doing that will actually in your Unity, oops, that's my game hub, in your Unity engine, it will put this again. By the way, just in case that wasn't clear, the reason why we're not reloading script assemblies is because Writer is actually compiling behind scenes all the time. So anyways, we have this now, and what we can do is we can click on Character Controller and just drop it in there. And then if we go back to Writer, we'll see that it says changed in one asset, unique change. If you click on it, and you can click on here and it'll open and it'll say it's right there, which is not super relevant right now, but it's good to know that this value is actually changed in the Unity editor and it's a unique value. So our controller is now available through the variable controller, and yeah, it's a character controller. Now, one thing about serialization, while I have your attention regarding it here anyways, there's other cool stuff that you can do with it. You can do, for instance, tooltip. So if you would do tooltip, and then you can write here, insert character controller. And then you'll see, I'll go back in a second, that it will say that. And other things that you can do, like let's say if you're doing an integer or something like that, you could even go range. And then you could put in a range like 0.0 to, I don't know, 1.0. And then whatever you put in here will have to follow that range. Now I'll show you that some other time, but I just wanted to point out that you can add tooltips, which can be super helpful as you're working with an editor, especially if you're working with a game designer who's going to make changes to things in the editor. So if I go back here now, I think you can get the tooltip by hovering over it. Yeah, so I hovered and it says insert character controller. It's right underneath my mouse. Hope you guys see that. All right, so anyways, that's how you serialize a field, and now we have a character controller. And with that character controller, we can do cool things now. So we can move our character around. So we can do controller, and as you'll see, it's a serialized field that is attached to a character controller. What are the options that we have? And if you don't know what you're doing, you can kind of look to this and see if there's something. Oh, here, move. I like that. Move. We want to move our character. Let's pick move. So let's have a closer look at move. So I'm just going to select it, press F1, and that'll take us to the documentation. And move needs a vector 3 that is going to give us some motion, because move is actually a script that will take the current position of your game object and then add another add a vector to it to move it into a given direction. So that's a lot of math that we don't have to do here. And it'll actually look into collisions as well. A collision might constrain the move even from taking place. So usually you'd write some code where x is equal to x plus a certain amount of speed, and then you do a condition to check if x would have the character run into a collision, and if that's so, then you don't do it, and if that's not the case, you actually run it. All that stuff you don't have to worry about because Unity is already doing that for you. So, this is really great. And we can just shut this down and create our vector that will have the movement then. So we're going to make a 3 vector. Here we go. And I'm going to call that vector movement, like so. And that vector is going to be equal to our player transform. And we are going to, let's see, player transform x times, oh wait, I'm doing something wrong here. Oh yeah, of course. Player transform doesn't probably have an x as, because yeah, it needs to be one of the unit vectors. So we're gonna take the unit vector for right. So this is pretty much yeah, what is it, 100, I think, or minus 100, I don't remember correctly, but like that's what it pretty much comes down to. And we're going to multiply that with our local variable x. So player transform times right is going to output whatever this value was that we saw earlier on the horizontal axis times the unit vector that will make it go to the right. And then we're going to add basically the same thing. Player transform, and we're going to do forward, which is going to be on the z-axis multiplied with z, which comes in from our get input or input get axes. All right, and then we are ready to do the movement itself. So the movement itself pretty much is just putting in the movement. And yeah, I mean, let's see what that does already, because I don't want to get ahead of myself because it might make things a little bit too complicated if I just keep writing code. So here we go. Let's see what this does. So I am going to make sure I find my camera first, because if my camera's in a spot where I can't see anything, well, then it's in a spot where I can't see anything, right? So let's make sure, where was my trainer? And just copy that.
5 hours later.
Okay, so I've gotten myself into a bit of a pickle here. I'm gonna have to sort this out somehow, because I accidentally moved my trainer around and like everything's a mess now. So, okay, here's how I'm gonna solve this. So first off, let's talk prefabs. I'm going to grab my trainer from here and just make a prefab. So I'm just gonna drop them in there. It's gonna be an original prefab that kind of removes the connection to the static mesh one, but that's fine. And this prefab, if you click on here, you'll see it has all the stuff that we put in there. So we can safely delete this guy here now. And we can find our spot. Here we go. That was a spot I liked. And I can put the trainer back. And everything will be there, because that's what happens with a prefab. It will take all the stuff that you edited on a game object in the game engine, and it will save it as something that you can easily use as an asset later on. All right, so we've got all that. Now I have to move my main camera again. So let's see if I can get a second attempt at it. So it's actually at 112.32. Okay, let's try this. So 112, here we go. Yay. So that was really not that hard. But anyhow, I'm gonna move the camera forward a little bit, and I'm going to use this small box here to just briefly position it a little bit. Maybe not in the middle of a tree. There we go. So that we can easily see our lovely trainer person character like that. Wonderful. And I'm going to save here, and I'm going to press play, which will put us in game, and see what happens. So now we have our game camera, and hopefully I'm going to press D. Something happens. So our character is moving around, is going back and forth. We are making progress, people. Now, if you're wondering, so let me turn on the keyboard display here for a second. You'll see that when I'm pressing the D button, we're actually going left. When I'm pressing the A button, I'm going right. So that is because we are facing the character. And if we, for what we actually want is we're going to put our camera on the back of the character. So we want A to make the character go into this direction, to their left, and D to their right, as opposed to ours. And forward and back works fine. The only thing that's not going great right now is, as I'm sure you can figure out, is that it's going way too fast, and we're going to have to add some code to slow this down a little bit. And we also want to add some code to make sure that this is going to work on every computer. So let's stop running the game and get back to Writer. So here we are again in Writer, and we can add a little bit of code to this. So the first thing that I would like to do is mess with the speed. So I'm going to multiply this, and as you can see, the controller.move, Writer is immediately going to say like, hey, this is motion. So that's kind of neat. This isn't actual code. Like if you look at this code and then other text editor, it's not going to appear. And I'm going to put down speed, and I'm also going to put something else down while we're at it. Time. Time is an interface to get time information from Unity, times DeltaTime. So why am I doing that? Well, let me open up the page on DeltaTime. So I'm just pressing F1 so I can see it. And with DeltaTime, actually, let me remove interface for a second. With delta time, it will give you the interval in seconds from the last frame to the current frame. So this is actually super helpful because if you're running your game on different computers, I'm sure most people who've played games before are aware that you'll have different frame rates. So the time between frames on different computers can be longer or shorter, which means that if our code is going to make adjustments to what happens in the game engine between each frame, depending how fast your computer is, that distance might start being different. So by multiplying with Time.DeltaTime, so delta time is the time in between those frames, you can actually compensate for that difference and make sure that speed and everything that is running towards an internal clock of your CPU or your graphics processor or whatever is all going to run consistently regardless of the system. So if you're doing anything that involves movement or time, you want to think Time.DeltaTime, because if you don't do that, it will cause to very interesting results on different computers. Okay, so anyways, we still need to declare speed. That's why it's entirely red here. So yeah, let's do that. So let's create a variable, and I think this should be a public variable in this case. So I'm gonna put the publics a little bit further out from the serialized private ones, and we're gonna call this one just speed. I think it's gonna be a variable. Probably a float would be a good idea for that. So let's call it a float, and it's going to be speed, and its default value, I think, how about something like 10? So yeah, a value of 10. By the way, in case I've not explained this yet, the reason why you have to put f behind a float is it's a little bit tricky. It's basically because, well, you're declaring a literal here, and if you put down just 10, Unity is going to interpret 10 as a integer. So that's going to make things weird because you want this variable to be a float. So you're converting it to a float anyways, but you want both of these things to match up really. So you can look into further detail on this. In general, you want to put an f behind every float to make sure that it actually turns into a float. So we're called the variable speed 10 float. I don't know if that's going to be too fast or not. I'm just putting in random values here. We're making this stuff up as we go along. And I'm going to go back to Unity. Here we are. And if we select our trainer character, we should be able to see the speed right here. And we are capable of editing it as well if we like. So what we're going to do is we're going to press play. All right. And we're going to start moving. And oh, I think this is a nice speed. Like, this is fine. Once we bring the animation in, we'll see what we want to do. But I mean, this is something that's fairly easily controllable, maybe on the fast side, but we could actually try to change it. I've never really done that on this project yet. So, but yeah, if I change that variable now, you'll see that the speed will change accordingly. So now it's 3. So yeah, 3 looks like a better value, and we can change that in the editor right now, or since we're working on the code anyways, we can set the default to maybe, I mean, 3 was kind of slow. Let's do 5, right? All right, so we have public speed, float. Yeah, and I feel like we have some good motion going on right now. And maybe that is enough for the first video on this here. And then in the next video, we can look at the jumping. Because if you're looking at this video, what we've got here is, as we're moving our character around, you'll see that we're kind of floating above the scenery, because whenever we go up a hill like this and we go back, we stay stuck. There's nothing that's pushing us down. So we kind of want to get some gravity going. And that's something that we can do in another video. All right, let's end this one here.